Bismillahirrahmanirrahim. FSC Chemistry, second year. Chapter 8, Aliphatic Hydrocarbons. In this chapter, we will learn how to name the aliphatic hydrocarbons according to IUPAC rules. The synthesis of alkanes, alkenes, and alkynes and their important reactions. The comparison of reactivity of sigma bond and pi bond. About the free radical nature of reactions of alkanes and electrophilic addition of alkenes and alkynes. The comparison of reactivities of alkanes, alkenes, and alkynes. 8.1 Introduction. Introduction. Hydrocarbons are organic compounds. Organic compounds, the compounds which contain carbon and hydrogen. Hydrocarbons, compounds containing carbon and hydrogen, which contain carbon and hydrogen only. It means hydrocarbons are those compounds which contain carbon and hydrogen only. The number of such compounds is very large because of the property of catenation. Organic compounds are very large because they contain a property which is so-called catenation. Catenation is a property of carbon in which carbon atom is bonded with another carbon atom. Okay, so many carbon atoms are interlinked with each other with covalent bond, and this property is known as catenation. Hydrocarbons have been divided into various classes on the basis of structure of the chain or size and nature of the ring. It means hydrocarbons have various classes, can be divided into various disciplines on the basis of their structure, chain, size, and nature of ring. If all the valencies of the carbon atoms in a molecule are fully satisfied, it means no valency is available, or valencies or bonds are formed with other atoms in the molecule are fully satisfied, and these cannot further take up any more hydrogen atoms. Then the hydrocarbons are named as saturated hydrocarbons or alkanes. Saturated hydrocarbons or alkanes, these are the compounds in which all bonds are formed with other atoms. There is no double or triple bonds. In these compounds, all bonds are singly bonded. No further atoms can be added in these compounds, and these compounds are called saturated hydrocarbons or alkanes. The compounds of carbon and hydrogen in which all the four valencies of carbon are not fully utilized, and they cannot contain either a double or a triple bond. Such compounds are called unsaturated hydrocarbon. As we know, carbon formed 4 bonds. If carbon formed bond with all 4 other atoms, same kind of atoms or different atoms, and they are formed with single covalent bond, then these are called saturated hydrocarbons. If carbon formed double bond or triple bond with other atoms, then these compounds are called unsaturated hydrocarbons. Those unsaturated hydrocarbons which contain a double bond are called alkenes. Compounds containing double bond, minimum one double bond, two double bond, or more double bond, then these compounds are called alkenes, while uh, compounds containing triple bond are called alkynes. Words alkane, alkane. Words alkane, a is replaced uh, with e to form alkene. Alkane contains single bond, while alkene contains double bond. The word alkane a is replaced with y to form alkyne. And these compounds contain triple bond. Classification of hydrocarbons has been shown at page 136. This page is 137, while a graph is given at this page, and this page number is 136. We can see here classification of hydrocarbons. Hydrocarbons are those compounds which contain carbon and hydrogen. Hydrocarbons are classified into 2 categories: open chain or acyclic hydrocarbons. Open chain or acyclic hydrocarbons. Open chain mean carbon are linked with each other and they cannot unite with each other reversibly, or its arrow cannot unite it with its tail. For example, this is CH2. This carbon is bonded with this carbon, and this carbon is bonded with this carbon. This carbon further this CH2, then this CH2, and they again recombine with first carbon. This carbon again combine with this carbon, and they form a closed chain. In this compound we see here a closed chain. So then this is closed chain. If they not form any closed ring, then these are called open chain. Open chain are acyclic. A mean without cycle, are acyclic hydrocarbon. In contrast, closed chain are cyclic hydrocarbons. We can see here a closed chain, this one a closed chain. In this compound, all carbon atoms contain single bonds. All carbon contain single bond. In this compound, we see carbon carbon-carbon, single bond and double bond. Alternate single and double bond between carbon atoms. In this compound, we see carbon at carbon-carbon double and triple bond alternately. Open chain compound further classified into saturated hydrocarbons and asaturated hydrocarbons. In saturated hydrocarbons, carbon-carbon bonds are single. There are single carbon-carbon bonds. We can see here carbon, single bond, carbon. Then this carbon is further bonded with three other hydrogen atoms. I can write here carbon, then one hydrogen is bonded in second bond, one more hydrogen is bonded in third bond, one more hydrogen atom is bonded. In this way, a carbon atom is bonded with three hydrogen atoms, and this carbon is further bonded with carbon. So a one single carbon is bonded with three hydrogen atoms with single covalent bond, while this carbon is further bonded with this carbon with single bond. So and this second carbon is bonded with hydrogen atom. Its more bond is formed with hydrogen atom, and last bond is formed with another hydrogen atom. We can see here this carbon is bonded with other carbon atom, single bond, single covalent bond, this single bond, this single bond, this single bond. There is uh, there is not formed any double or triple bond. This is the example of saturated hydrocarbon. This one is the example of alkene. There is formed a double bond. There is a double bond between carbon and carbon atoms. I can write here carbon, hydrogen, carbon double bond. And a double bond is formed between two carbon atoms. This carbon atom contain four bonds, one with hydrogen, second with another hydrogen, and two bond with this carbon, and this carbon with two bond with this carbon, one bond with this hydrogen, and one bond with this hydrogen. So this compound contain a double bond between two carbon atoms, and this one is the example of alkynes. In alkynes, there is a triple bond between two carbon atoms. I can write here carbon, triple bond, carbon, and hydrogen. And this is the example of cyclohexane. Cyclo means cycle, a closed ring. Hexane means six carbon. I can this is already written CH2, and it means one carbon atom also contain hydrogen. I can write here hydrogen. Second example is aromatic hydrocarbons. Aromatic hydrocarbons, for example, benzene. This is the example of benzene. A structure formula of benzene. I can write a structure of benzene in this manner: carbon, carbon, carbon. There is 6 carbon in a benzene ring. 1, 2, 3, 4, 5, and 6. Every carbon contains a single hydrogen atom. Carbon. In benzene, there are alternate single and double bonds. There are single and double bond between 2 carbon atoms. One single bond, then double bond, single bond, and double bond, single bond, and double bond. So there are alternate double bond, single bond, double bond, single bond, double bond, and single bond. In closed chain hydrocarbons, alicyclic hydrocarbons, cycloalkanes, there is no double or triple bond. Aromatic hydrocarbons like benzene ring. So this is the classification of simple classification of hydrocarbons on at FSC level. Hydrocarbons: open chain, closed chain, open chain, saturated, and unsaturated. Saturated alkane, unsaturated alkene contain double bond. Alkynes contain triple bond. While alicyclic, cyclic compound with single bonds. Aromatic, cyclic compound with double bond or triple bond like aromatic hydrocarbons, example benzene.